Okay, so yeah, welcome once again to today's class. So for today, what we are welcome once again going to today's class. So for today, what we are going to have the review of the materials that we are going to have the problems on the addition of matrices, material, the subtraction of matrices, problems on the addition of matrices, and the subtraction of matrices. So we are just going to the questions that we had matrix and then so we are just going to just discuss the questions that we had from the and what we our solutions and then what we got our results. So that's the what basically what we did and then what in today's class results. Then basically in next week's class when we meet during the first session, that's when we start with the next week's class determinants during the first session. That's when we start with the determinant as we are going to today's class doing is what we are going to be so we are going to just have a little recap. So on Monday's class just have a recap matrices are. So what on Monday's class what matrices as what matrices are. So what matrices why we need matrices that the various matrices that we have in that the various types of matrices that we started with the operations that are types of matrices. Then that they started with the operations that are done. We saw the rules that we have the follow of matrices before we can add matrices. We saw the rules that we have to follow before we can add matrices of matrices that the rules that we have to follow when it action of matrices the various that we have to follow when it comes to scalar multiplication and then the multiplication that the scalar so multiplication and that's basically multiplication we end the matrices. So class I've shared where we end the lecture notes. So as I said, the lecture notes that we are having the maths lecture notes. So as I said, the lecture notes that we are having the maths check the WhatsApp groups for the latest version. So the latest version will be the last. Always check the WhatsApp shared for the latest version. So I'll try and change the last. So if you check the first one that I sent was so I'll try and change the name version one. So if you check the first one that I sent was maths one lecture introduction to matrices. So when you do the determinant one, so I'll change the introduction to matrices. So when you name the helps you to determinant one, so I'll change it currently as determinant. So that the name helps means we are doing where we currently are. So one for differentiation determinants means that's where we are doing determinants. And then there's slide maths one for every single thing. So this means that's where we are. And then there's slide routine every single questions as you can see. So I haven't updated it. So I guess the addition and subtraction as you can see. So the first group remove to the multiplication addition and subtraction and then use symmetry and then remove to the multiplication question. Then I also included the link symmetry. So this and then link when you click on it to questions. Then I also included the video recording. So this loaded the link when you click on it to lead you to lead you the video recording. I've uploaded that playlist is where I'll be. So it will lead you uploaded all the video records. So that playlist is where I'll be. The playlist uploaded video for that particular session or lecture. The playlist uploaded video so that particular session or lecture you are able to be uploaded there so that and then you just go to the playlist you are able exactly what's taught. So that and then basically what exactly what the playlist is about. So that's what will be basically then what the playlist is about. So that's what we'll be seeing. Yes, Thomas, you can unmute and then talk. Who's yes, Thomas, you can unmute and then Mr. Thomas. You've raised your hand. Thomas. Do you have a question? If you have a question, you can just unmute. Raise your hand. Do you have a question? If you have a question, or here yes, then I'll provide unmute and then whatever you are asking. Or here and then I'll provide the feedback on whatever you are asking. Do you have a sense there's no question or just okay. continue with what I was saying. Since there's no, you are going to be going to continue with they are not going to be teaching you exactly. You are going to be solutions. They are not going to be teaching you exactly. You'll be presenting each question as we can go through everything. We will not be able to go through all of each question as much as we can go through everything. We will not be able to go through all what the solutions that we had. What were the solutions that we had? What the solutions that we had? What were the solutions that we had? And then what is the correct reaction so that you have that we are supposed to have gotten. So the first that will be starting with is the gotten. So the addition of matrices that will be starting with the addition of matrices. What's the addition of matrices? So with the addition of matrices, what then we have a question basically. Is that we have a question? Okay. So the addition of matrices, what we know is that they have to. So the addition of matrices have the same dimensions. They have to the same matrices have the same base dimensions. So the same addition and then the subtraction on them. So that's basically addition and then the subtraction on them. So that's basically the when you are given a question and try and see the dimension that you note when you are given a question and you try and they are not the same dimension you can and see if they are the same. If they are the next that you check is that operation just that adding or subtracting that responding you just start adding or subtracting responding values. Please give me a moment here. As I was saying, for the additions and subtraction, you add or subtract the corresponding values and subtraction. You add or you subtract the corresponding values. So the first question, basically, the first question we have. So the first question of matrices. So for that, the first question is addition and subtraction of matrices. So for that, we have three questions. So for question 1, question 2, and then question 3. For question 1, question 1 says giving the question we have values for matrix. Question 1 says giving that, and then we had values for matrix A and then matrix E, matrix C. So those are the values that we've been given, and those are the matrices that we've been given. So what we have values that now given, and those are the matrices that we've been given. So what we have to do now. So the first question is find the following if possible. So the first question in brackets find the following operations might not be so the if possible in brackets shows that some of the operations might not one some operations are possible. That's a first clue. So it shows you that one some operations are possible, not two. If some are possible, then it means that some operations to convey. So you just keep at basic and then the if possible conveying. So yes, so if possible notes and we are supposed to find the following. If possible, so A, we are supposed to the first question I the is that following. We are supposed to find so the summation. The first question I is that we are supposed to find the summation. So matrix A is and then this matrix B. This so matrix A is matrix this matrix is selected and then is matrix this matrix we are supposed to find matrix addition of the two this matrix we are supposed to any find solution addition of the two added matrices. If any solution is this addition possible get or added it's not possible. That's the first question. Is this addition possible or how it's not possible? That's the first addition. And this is a question for us. If you how you proceed with the addition. Any idea question for us? If you have them, you'll be called. Any idea? Speak. Raise your hand and then you'll be called to speak.
Yes, madam. The A is possible. But the element in A plus A and B
A is
are
possible.
same.
The
But the
first
element in matrix A and B
Yes. So the
are
first
same.
is it possible? Yes. So why is it possible? Because so the elements are the same. Their dimensions so why is it possible? Because the elements are the number of their dimensions are the same. The number of rows in B is 2. The number of columns A is 3. The number of columns in B is 3. The number of columns means that this is possible. The number of columns in we can do 3 addition. It means that this is possible. So it means that the addition we can do the addition. How is so how do addition done? How proceed with the additions? How is the addition done? How do we sum them up? Yes. Yes, Mr. Stephen Winkle. You can unmute and then yes. Yes, Mr. Stephen Winkle.
Okay,
You can
madam.
unmute and then you
Uh,
speak.
to find
Okay, madam.
A plus B, then you
Yes.
have to pick the set of to find A plus
Yes.
B. So then you
Yes.
have to pick the set of pick the set of it. A negative
Yes.
1, 2, 4, 2, so 5. Then pick the set of it. Then negative 1, 4, 2, 5. That's the B, the set of B. Then plus so it will be 7 plus, that's the set of B. And then negative 3. So it will be 7 so with this 1 0 with this when you are continuing 6 you will pick so with this with this when you are continuing
Yes.
and you pick you first of all you add them the column
Yes.
and
Yes.
that's you first of all the A column the first that's the first column the A column with the second column the first column with the first row with the you find out is the second column and then with the first row you find out is negative one you find with the B2 so with this you pick the first row that you find that so with this negative one the first plus 7 you do it as then you come to the next column negative 1 plus 7 2 plus then you come to the next column and then you come to the next column plus 0 1 that's plus and then the negative and then you come to the next column so the plus 0 that's plus 0 but there's the negative cancel the plus so you do same the down 1 minus 3 4 plus if you do same and then the down 1 plus that's 0 and then 3 plus that's and then 6 5 plus bracket 0 and then 3 so after that then you add them 6 into bracket when you add them you get something like then you add them 6 when you add them that's the first row you get something like you get 6 6 3 that's the first row 3 you get and then the next row you get 6 3 11 3 and then 9 the next row you get 6 11 plus and then 9 will give you to bracket so A plus B 6 3 negative 3 and then down will give you 6 11 9 6 3 negative 3 and then the down will give you 6 11 9
So that's
that's all.
what is done. So the answer is that we are supposed to do exactly said what that we check so that the first they have that same size or the same dimension. We check that same number they have the same size or the same dimensions or the same number. So if they have the same or they are identical in their sizes. So if they have the next that you do or they are identical in their summations, then the if you are going to be doing is that what you start with the summations. So if you are going to be doing summations, column for each row, how you want to we check the sum the corresponding row value. So if you are going row wise, you check the first row in matrix A. So if you are going the first row wise in matrix, check the first then you add matrix A corresponding check the first row in matrix B. Then you sum the negative value. So if you are using matrix A, then we'll go to the next sum the negative 1 and then 7. Then we'll go to the next sum the minus 2 and then the 0. Then after that, you go to the minus 3 second row 0. When after that 4, you go to your 2, and then 5, second row, and then where 0, you sum and then there's 6, and then 3, and then 5. So after that you then compute each value, and then there's 6, what you get finally 3 in your matrix. So after that you then compute each value, then what you get finally in your matrix is known as matrix A plus. So that's the summation of the matrix. First you check dimensions. So that's you basically start the process. If the dimensions are okay, dimensions, so we then summation, then start subtraction. If the dimensions are okay, start with the additions, and then your subtraction. Then you start with the additions, and then your subtraction. Desmond hasn't spoken. Mr. Desmond, you have your hand up. You have a question. Desmond.
Yeah, please. If I heard him clear, I heard him saying the A plus B. Yeah, please. If I heard him clear, I heard him saying the A plus B. The answer will be. Please, I wanted to find out where from 3 minus 3 and 6, 11, 9. Please, I wanted to find out where from. What if I heard him clear? Did he say 11?
And then 6, the bottom one, 6, 5, and
If I heard him clear, did he say 11?
6,
9.
the bottom one, 6, 5, and then
Okay, because I heard him saying 11, so I wanted to be clear.
no, there's no 11. Yes. So 1.
Okay, because I heard him saying 11, so I wanted to be clear.
No, there's no 11. So 1, 2,
Alright.
6, 7, and 6, 5, 2, 1, 2, 3, minus 9, 3, 4, 2, 6, 5, 2,
Thank you very much.
6, 3, that's 9. We get.
Yeah, thank you very much.
So that's what B plus A. Is it possible?
Yeah.
Let's go to the next question. B plus A. Is
Yeah,
B
B
plus A
is possible.
Yes. So this will end up getting the same. Is
Yeah,
B
B
plus A
is possible.
Yes. Then the next end up getting the C values. So C is this. C then the next D is this. Matrix C and matrix C is this. Can we add C plus D? Is it possible C and matrix D? Can we add them? C and then matrix. Is it possible to add them? Matrix C and then matrix D. Ideas. Yes, Mr. Kuma. Unmute and the ideas. Yes, Mr. Kuma.
Hello?
Unmute and the button.
Hello?
Yes, yes.
This is possible.
It's possible.
Hello?
Yes, we can add them, right?
This is possible. Yes.
It's possible. So how do we do the addition? Let's just, we can add them, right? And then go
Yes.
to the next. So how do we do
The
the
square
addition?
from
Let's
1
just
plus
quickly go to
11
it, and then yes, go to the
2
next.
plus 5. The square from 1 plus 11 9 plus 4.
Yes,
2
exactly.
plus
So that's
5.
how
Negative
we
4
do
plus
it. So
9
1
plus 12.
plus 11, exactly. So that's how we do it. Negative 4 plus so 1 plus 11, 2 plus 5, negative 4 plus 0, and then 9 plus 12. So we'll go to the next question. That is C minus D. So we'll go to the next question. Can we subtract D from C minus D? Is that possible? Can we subtract D from matrix C?
Yes, it's possible.
Yes, it's possible. So we just do the subtraction. So
Yes,
do 1
it's possible.
minus 11. Yes, it's possible. So we just do the subtraction. So do 1 minus 11 minus 2 minus 5 minus 4 that question is 0 and then 9. So is D minus C possible? Yes. That question if C minus C is possible, so is D minus C possible? Yes. If C minus D is possible. Now we have matrix A plus matrix E possible. So the first now we have matrix A plus matrix E possible. So the first matrix addition last matrix. Is that possible? Can we do the addition? Yes, Mr. Thomas. Yes, Mr. Kumar.
The A plus balance.
E.
Yes. Because the first one, the number of columns, because the first one, the number of columns, and then the number of is different from rows to the number of columns, and then the number of rows to
possible. The number of the sizes are different. The number of columns here, the number of the sizes are different. The number of rows here different from the number of that addition the number of columns here. Then we have b minus d is not so this is b. Then we have b minus. Is it possible for us to subtract them? And then this is d. Is it possible for us to subtract them? Minus or addition? Let me check again. Yes, minus b minus d minus or addition. Let me check again. Is it possible for us to subtract b minus d from matrix B? Is it possible for us to subtract matrix D from matrix B? Any ideas? Yes. Mr. Ekuma, the ideas, and then you speak. Yes. Mr. Ekuma, Derek, you can unmute and then you speak. Adding. So we are subtracting B. B is this one. This. So we are subtracting B. B is this one from this B. So we are subtracting this. Is it possible or not? D from this B. Yes, it's not possible. So we can't or not do that because their sizes are not possible. So we can't say do. So all you write their sizes are totally not if the same. So all you write there is possible. Then you can write an explanation. If their sizes are not possible, then you can write an explanation. Something small. Their sizes are different. They don't have. Let's go. So let me quickly try. Just something small there. So the next is. So let me quickly try 3a. I can remember. This is not addition. So the next is. So this one is the scalar. This is not multiplication one. So this one is 3. So this one is the scalar multiplication one. So this one is 3. So it means that the factor that has been given to this matrix 3. So various items or various elements in it. This matrix A, so that's basically the various items or the various elements. This one is by 2C, so that's basically what that question is about. So the first is that this one is check if we can actually add plus D. And then D. So the first is that check if we can actually add so, and then we do the so we can add, so we find the scalar of, so we do the addition. So we find the scalar of Mr. Evans. You can only so we have, and then we add from there. Mr.
Yes, please. The
Evans,
line was breaking earlier on, so I didn't hear what you said.
Oh, okay.
Yes, please. The line was breaking earlier on, so I didn't hear what you said.
Going through the questions. So we've raised the question. Going through the questions. So we've raised the question. The B minus D. So this is B right here, and then this B minus, and then we realize that we can't subtract matrix D from, and then this is D because they are, and then we realize dimensions are different, they are not the same. This one matrix is having their dimensions are having they are not the same. This one will not have able to do the subtraction, but this one then we went to the next one will not be able to do the subtraction. Then we went to the next one, which is 3a. So 3a basically means we are scaling. Went to the next one, the scaling factor is 3. So 3a basically means we are scaling. And the multiplied is 3. So we are the elements, each element to be multiplied by 3. And then multiply 3 in that the element. So each element. And the next question was 2c plus in that way. So first we have next question even add 2c plus. So if you are checking, so first we have to check if we can even add also 2 by 2, which means so if you are checking the addition by 2, so what you do is that first you get your by 2, which means that you multiply addition. So what after that is that first you get your 2 and then you get your final. So you multiply distribution. Then after that you add the next is 5 final minus 4e. Then so where is the next is 5e. Okay, this is B 4e. And then this is E, and where so their dimensions are not the same. This one has, and then 2 rows, but this has 3 so their dimensions has 3 columns. This one has, but then this has 2 rows, but this has obviously this has 3 columns, but then this has they are not the same. So then obviously that their dimensions are even by looking at them that we can't they are not the same. So then we see that their dimensions subtraction operation that we can't perform the two them. subtraction, so you can see for some on their the addition and the subtraction that we are, so you can see for some it's not possible, yeah, and then the addition and the subtraction that we are being asked to perform is not possible, it's because and then their dimensions are the same. The only reason why it's possible if you are given any question at all are the same. So as I said in the previous class, either if you are given any question at all, mainly for the addition and the subtraction, the first check either addition have the exact mainly for the addition and the subtraction, you dimensions, or they look the same, or they have the same sizes, or they have the same dimensions, or they look the same, or they have the same sizes, or they have the same number of contents. See that how okay, this operation will be possible on that, then they are able to see that okay, this operation will be possible. So let me do the operation. So we'll be going down a little. So this is the second question B. So we'll be going down a little. So this question is also on addition and then subtraction. Question 2. So for this, it's so this question is also on addition and then subtraction. So it shows that so for this some it's also stating find not the following if possible. So it shows that some things so might not be possible. Give me a moment. So it means that some operations might not be possible. So if so, it means that some operations might not you know that the issue possible. So if some operations might not be possible, the first is you know that the issue would mostly come from the dimension that they have. So then you first check their dimension. If it's the same, then you proceed from there. If it's first check their dimension. If it's the same, then you proceed from there. If it's not the same, you know that obviously. So let's start. So we are going to go through. So this one will be a little quick. So let's start. The first question we are going to go through. A plus B. Can we add A and B? So the first question A and matrix B. A plus B. Can we add A and B? So matrix A and matrix B. Is it possible for us to add them? Yes. Yes or no? Is it possible?
They are not possible. You can add them.
Yes, we can add.
They are not possible.
They are not the same.
You can add
looks
them.
like it is twice. We can add. If you look at them, they are not even the same size. One looks like it is twice the other one. So B minus C. So is it possible? We can't add them. B minus C. Is it possible? Yes, Mr. Thomas, you can unmute it. B minus C. Mr. Evans, you answer the Mr. Thomas, you can unmute Mr. Thomas. B minus C. Is it possible? Mr. Evans, you answer the
possible. The rows and the columns are the same.
Exactly.
It is possible. The rows and the columns are the same.
Exactly. So they are the same. They have the same subtraction, everything the same. So A minus D, the subtraction A minus. So A minus is that possible? A minus D. Is that possible? Yes, Mr. Kuma Derek.
Please, it's not possible.
Yes, Mr. Kuma Derek. One is the row matrix, the other one is the column matrix. One is the row matrix, the other one is the column matrix. It's not matrix D, the column matrix. A is a column matrix. We can't add the D is a row matrix. Then the next is B plus add the two. B plus E is that possible? Then the next is B plus E. B plus yes, E is that possible? Can we add B and E?
Yes, please, it's possible.
Yes, it's possible. We can add them. They have the same.
Yes, please, it's possible.
Sizes. Yes, they have the same. We can add them. They have the same sizes. And they have the same size of this means that we can then add the last. Let me see if it's really the last. Yes, that's the last. Is the last E minus D. Yes, that's the last. E minus D. Subtract them. E minus D. Add them.
Yes, please, it's not possible to add them. The sizes are not the same. Yes, please, it's not possible to add them. The sizes are not the same.
Yes, so we can't. Their sizes are not the same at all. They are not that's assigning. That's what we go for. Sizes not things that are not the same. So that's sizes that we can add sizes not the same. We go on and see sizes what we are adding and what we can add or subtract. Then we go step by step manner what we are adding and what we are subtracting. So this one has some scalar by step multiplication questions here. So this one has some scalar go through this one. Multiplication questions here. 3. So question 3 go through this is one. The same. Given that question have 3 A, B, so question 3 and E is the same. Given that this one we have find A, B, the following D if possible. And then the various find questions the following operations that we are supposed to. And then the various we have the questions or the various operations that we are supposed to. 2A plus B, so twice of matrix. So the first is plus matrix B plus B. So the first twice of matrix before you do the 2 plus matrix. Can we add matrix to the first and then consider before you even do the 2? Is it possible for us? Can we add matrix A and then matrix B? Is it possible for us to add them?
It is impossible.
Yes, it's impossible. I like that.
It is impossible.
It's impossible. Yes, cannot possible.
Yes.
I like that. It's not possible. It's impossible at all. You cannot say
Yes.
so if that's not possible, so as I said, if there's a question like that, then just state. So if that's not possible, so as I said, if there's a question like that, add them. Then you explain why. So this is not possible to size is different from this. Add them. Then you explain why. So this based on the matrix addition from this. We only add things that are because based on the matrix addition rules, we only add things that are. So the next question we have here is 4D minus E question. So the next question we have here is 4D minus D. And then this is B. Can we subtract them? This is D. Is it possible for us to do B? Can we subtract them? Yes, God's will. Is it possible for us to do subtraction?
Yes, it is possible.
Yes, God's will. Yep, it is possible. So then
Yes, it is possible.
with the operation. So the first thing that you do is that you find ahead with the operation. So the first thing that you do and then you multiply each element by 4. So you take the matrix you have 4D and then after that you subtract elements by 4 from then you have 40. Then after that you subtract this matrix your final from it. So then what you get that's the answer that is your final thing. Then let's move on. That's the answer that you have. 3C minus then let's move on to the next question. That's 3C minus is that possible? Sir? Is it possible for 3C minus A? Is that possible, sir? Mr. Derek Kuma. Is it possible for
This is possible.
Derek Kuma? Minus yes, that is possible. So they have the same number of minus. They both have 2 rows. That is possible. They both have. So they have the same number of rows. So because of that, 2 rows. It's possible for us. They both have 3 columns each. So because of that, it's possible for us. The next has 3. So we have 3 separate matrices. The next has 3. So we have 3. So the matrix separate matrices are 3 different matrices that we are supposed to be matrix D. So the matrices and then matrix are so B matrix we are considering this and then matrix E and so BD and then so we are considering this. So these 3 matrices and what we are doing is we are performing the addition. So these operations and what we are doing is we are performing the addition operation possible on or not. So this operation is it possible yes, God's will or not?
No, please, it's not possible.
Yes, God's will. Why isn't it possible?
No, please, it's not possible. If you
why isn't it possible?
look at B and D, they have the same. If you the same look at B and the way they were positioned, they have the same. If you want the same, if you want to add element and E, the way they were positioned, they are different. They're the same, but if you want, they are different. If you want to add it with E, they are different. They are different.
The first.
Madam, I wanted to answer. It's not possible. Madam, I wanted to answer. it's not possible. And then the D is also in a column form. But looking at the E, I mean, form. And then the D2 is also in a column form. But looking at the E, and then in three columns, so it's not possible. In two rows, yeah, and then in three columns, so it's not possible. The first two, yes, that's the B and then the D would have been possible.
Part of the question. Because
The first two, yes, that's the B and then the D would have been possible.
Different. But then because
Yes,
it
yes.
brought in the E, the
The
operation
E, yes,
will not different. So then it means that
yes, possible.
say that
Yes,
the operation is not will not possible. Possible. That's
possible.
say that
Yes.
this is not basically possible. What we have. Then the last one that we are going to be looking at is then the last this one 3C that we have C looking at is the this one 3C. So we have first matrix, the middle matrix, and then the last matrix. We are supposed to be performing addition and middle matrix, and then the last matrix. That we are supposed to be performing addition and subtraction on them. Is that possible or not? Who has it? So let me see who has raised their hand. Okay, let's see who has spoken next. Thomas, Boabe, Thomas. So let me see who has raised their hand. Let's see who has spoken next. Thomas, Boabe, Thomas.
Madam, the E
And then we speak.
answer is impossible because the E
Yes.
answer is impossible. But if the A 3C and E 2E, but if that one will be 3C and E, so I see the answer is impossible. That one will be
Yes.
so I see the answer is impossible.
Yes. So they have the same sizes. The first matrix, the second they have the same, and then the size. Sorry, the first matrix, the middle, the second matrix, and then the last. Sorry, the first matrix, the middle, the last matrix. Stephen, the last. Stephen.
Okay,
And
madam.
then the last matrix.
He was saying it's impossible.
That's what I was saying.
The last
It's
one.
possible.
He was saying no. He said it's impossible.
That's what I
That's
was
the last
saying. It's
one.
possible.
Yes, but no, he said it's impossible because yes, they have the same size. Yes, but looking at it, it's possible because yes. So yes, when they have the same size, they are working on them to be possible. So when
so
like
the first thing
they are working on them to be possible.
sizes. So if you look at the sizes, so the first thing that two rows. So A has two. So if you look at the sizes, C has two rows, and then E has two rows. Then A, C has they all have three, and then E has columns respectively. Then A, they all have three, and they have the columns respectively. If they have they all have three columns, means that they have the same operation. If they have the same size, so if you are going to mean that the operation, the first operation starts with on them. Three. So if you are going to do the scalar operation, first C will start with then we have 2E. So we'll do the scalar multiplication. Then when we are done, we just combine it. So we'll do 3C sum. When we are done, we just combine it. So we'll do what you have 3C minus plus the A matrix minus what you had for the 2E minus and then you just the A addition. So if you are doing this, what you had for the 2E, the 3C just first element. So if you are doing 3 times 1, 3 let's just take the 3C, the first element to be 3 times 1. So we have gotten 3 minus 0 plus 0. We have gotten 3 minus 2 plus 0, and that would be the first would have gotten 3 minus 2 plus 0, and that would be the first in that slot or the first item. So please let's do the same. If you are doing next and then addition that or the subtraction. So let's know if you are doing the if they addition have the same size and the subtraction. They have the same size. See, they have if they have the same is it the same number? So the columns same is it the same? They have the numbers. Is it the same number? If they have the columns the same is it the same? Then it means that it's going to be possible, right? The same don't have, then it means the same number, then it's not possible. So for things that are not possible, if they don't have just try the same number, then it's not possible. So for things that are not possible, you just try and then you explain, you just go ahead and then you break the question down and you just go ahead and then finally break your find the question down and do a step by step, and then finally get your final answer. So that's so we are going to the next step. The next is on the multiplication. So we are going to the next step. The next is on the multiplication. So the multiplication, we are going to look at some the multiplication. Matrix multiplication, because the addition and subtraction had some of the scalar multiplication because the addition and subtraction has some of the scalar multiplication. This and then we have section focused mainly for matrix multiplication to be possible, and then we have to remember that number of matrix multiplication in the first matrix should be the same as that the number of columns rows in the first matrix should be the same as matrix number. So you check your first matrix, how many columns do I have? Second matrix, go to the second. So you check your first matrix, how many columns do I have here? Then you go to the second matrix, then you check the number of but then before we go have and continue with that, I'm sharing the link. But then before we go for the attendance, I'm sharing the link to this session that we have, the attendance, the Monday attendance we had, and then this session that we had, Saturday session, the Monday session that we had, yes, and then the present Saturday session that we had that. So you just mark we are present, yes, not present attendance recorded, so that we are able to get the attendance recorded. So I'm sharing the link. I'll be done sharing it soon. Okay, so let me share the link. Okay, so I have pinned the message. So it's a Google form. So I have pinned. So you just enter your name and then your you just enter your then session 1 attendance you record, session 2 attendance you record, and then session 1 attendance you record, session 2 attendance you record that, and then so session 3 attendance. Let's do that. I'll be record that ending the what is it called? Let's do that. I'll be allow responses. I'm coming. I have to allow responses. Where do I do allow response? Please, I'm coming. I have to allow responses. Where do I do that? Okay, over here. Okay. So you can submit response. Okay. So you can submit response. Okay. So yeah. You answer someone, you have a question. Okay. So yeah. You can unmute and you answer someone, you have a question.
Yes, please. Concerning the
you can unmute and then you speak.
okay, please concerning the registration. Some of us don't have the IG.
Yes, that's
okay. Please concerning the concerning the registration. Some of us don't have the IG.
Yes, that's what's correct. If you don't have ID, please you put fresher. So you ensure that your name is spelled correct. If you don't have, then you put fresher for the ID. So if you don't have, use fresher. Then yes, you
Okay. All right. Okay. Thank you.
yes, So you just be taking
Okay. All right.
that
Okay. Thank you.
means that. So you just be taking ID plus the others. You just take for me your name and then the ID plus the others. You just take for me. Okay, so let's start with the multiplication. The multiplication so we have. Okay, so let's start with the multiplication matrices. The multiplication so we have do some multiplications of them, and then we are supposed to the matrix multiplication. So what we are, this one is focused on the matrix to do the first case. We are supposed to so what multiply matrix A. Supposed to do the first matrix. We are supposed to multiply matrix A. So is it possible to multiply A and B? Remember, so A and B for matrix. So is it possible to multiply A and B? Remember the rule for matrix. So the columns, as we said, it's the number of columns in the first. So the columns, as we said, equal to the number of rows. The rows in the first should be equal to the number of rows. The rows is the horizontal expression. The second half, that is that A and B. Let me possible with the expression that we have. That's the A and B. Let me see.
Okay, please. Yes, madam, it's possible.
Can unmute
because with the egg, it has two. Okay, please, yes, madam, it's possible. Rows, whilst because with the egg, it has two rows, whilst
has
the B has two columns.
the has two rows.
Column one, the B has two rows, two columns. Two rows.
Yes,
Yes,
it
please.
has that we can do
Column one, the B has two rows. Yes,
if
two
you are
rows. Yes,
multiplying, it
please.
says that you multiply through multiplication. So if you are multiplying, you say you multiply through times 3. So you take 1 times 2 plus 0 times 3. 1 times plus 0 times 2. So you see, at the end of the day, the multiplication has transformed the results to. So you see, at the end of the total result has 3 has transformed the results columns now. For the total result has 3 have that. Then if you columns can do B and A, so if you can do A and have that, then B and if you can possible B and A. See for the addition, if we can A and A plus B, it's B and A possible plus A. See for the addition, if we can do A plus B, we can obviously do A times B. But for multiplication, is can we do B times if we can do A times B, which is possible? Can we do so? Remember the rules is the number of columns B equals. Is it possible? So remember the rules is the number of columns B
Please,
equals the number
madam,
of
the
rows.
first
Thomas,
question
why?
A. You say A and B. Please, madam, the first A is 2 by 2, and the B is 2 by 3. And B. Can you multiply the 2 together? And the B is 2 by 3.
Question is possible.
Can you multiply the together?
Two rows. Yes. So you are checking the number of columns. So we have two columns.
It's possible.
The number of two rows in the second. So you are checking the number of columns in the first. We have the number of columns here. We have the second rows. So if you are it's possible. We have for us columns here. We have two rows. Then it means it's possible. So it's unlike the addition and subtraction where they have to have the same size. So it's unlike the addition and subtraction where they have to have the same size. Number of columns in the first for multiplication, what we are concerned with should be equal to the number of columns in the first, in the second matrix that you have should be equal to the number of columns in the second one that you have. To the number of columns. The number of columns, if they are the same, should be equal to the number of columns you can do that. If they are the same multiplication, then it means that you can do that. Particular multiplication.
Please, madam, I'm still confused because the B is 2 by 3. And the A is 2 by 2. I'm still confused because the B is 2 by 3 and the A is 2 by 2. So I want you to explain about the 2 by 3 can you can multiply the 2 by 2 by. So I want you to explain about the 2 by 3 can you can multiply the 2 by 2 by the. You see the B 2 by 3 is 2 by 3.
The issue that so we are checking the B.
You see the B is 2 by 3.
And then so we are checking
and the A is 2 by 2.
Yes. So for the first A, the question A
and the A is 2 by 2.
Yes. So for the first one, which is the question A, that's A times B, that's possible.
Okay.
But then for the second one, which is B times A plus B and B plus
Okay.
A is the same. That's why I was asking that if A plus works like that and B plus A is the same. Let's see if multiplication is works for addition. If you are adding A and B, if you turn it and you do B plus A. Because for addition, if you are adding A and B, for multiplication, for this example that B plus A, we see that nothing have A times but then for multiplication for this example that even if you flip it, that it doesn't have A times B, which was possible, and we are doing it if you flip it doesn't mean the number of columns we flip it in the doing is 3 times, but the number of columns is 2. That one is not B is 3, but if the number of rows A times A is 2, the number of columns in A is 2, but if it's the number of A times B is 2, the number of columns in A is 2. So those is the number of rows matrices that we are concerned. So that is still the same. So those is the same, but just because matrices that we are concerned with, it's still the same multiplication. Like the order just because that we are doing, whether it's A times B or the order times A, like the order makes one equation that we are doing, whether it's A times B or B times A. It makes one possible and then the other is not possible. So you just take note. The third question, is then and then I. The third question, Is that possible or not? And then I. Is that possible or not? D and then yes, Kumadere.
This is not possible.
Yes, why is it not possible?
Number of columns are three
Why is it
in
not
the D.
possible? Yes.
The number of columns are three in the D.
Yes, that's a trick question.
I can't
So where
find
is the
I.
I? Yes, that's a trick question. Where is I? So who can tell me what I is? Where is I? So who can tell me what I have we included I? Though we haven't given you what I is. What is I and why have we included I? Though we have who has an idea of what I is? Who has an idea of what I is? Any ideas? Ideas. It comes from the types of matrices that we have. That's where the I is. It comes from the types of matrices that we have. That's
Is
where
the
the I
identity
is coming
matrices?
from. Yes, I is
Mommy,
identity matrix.
is the
That's
identity
why
matrices?
yes, I is identity matrix. So this one is more of a that's why an application question to see if you remember what identity. So this one is more of a an application question to see if you remember what identity matrix. So if we see I, we use I to represent identity. We are using the I to represent identity. So if we see I, so this one we are saying that you are multiplying the matrix identity matrix. The identity. So this one we are saying that you are multiplying the matrix D with the identity matrix. So would that be possible? Do we have any ideas? Let me see. Kumadere, do we have any ideas?
Mommy, it can be
Let me
possible.
see. Kumadere, it can. Yes, not it will. It can.
Mommy,
Because we
it can be
haven't
possible.
stated if the it's not it will. It can. 2 by we haven't stated if the identity matrix is so with this you assume whether the identity matrix 3 by 3. So with this you assume whether the identity you do your calculations by to be easier if you just assume it and then from there you then the number of calculations by to then easier if you just assume the number of 3 by 3 and then you are able to do the calculation from there. But if you assume that it was and then you are able to do the calculation from the identity but if you assume that the number of columns here will not be by the number of rows, identity means that the number of columns here will not be equal to the number of rows. Then so the I, the not question D, the ID, it also follow the same. So the I, the question D, the I, the next that we have is C, D, and then thinking in the same logic. So the next that we have is C, so this is C, and then this is D. So the C and D, so this possible, is C, and then this is D. So the first can we multiply C and D possible together? Can we multiply C and B together? Yes, Kumadere. Yes, Kumadere. Recording the attendance. Yes. Yes, it's not because the number of columns in C is 1. Yes, and the number of rows in D is 3. Columns in C 1 and 3. They are not the number of rows in D is 3. What of D and C? The opposite they are not equal. Raise your hand earlier. What of D and C? The opposite with Mr. Evans. So the opposite we have swap it now. Yes, Maxwell. D and C. So the opposite we have swap it now. Yes, Maxwell. Who is speaking?
Hello, madam.
It is possible, madam.
Yes. Hello, madam.
It is possible, madam.
He has even said it is possible, madam.
Yes, so sorry. That is
He has even said it is possible, madam.
yes, so that is possible because equal to the number of rows that we have. So you see this another example of the AMP is equal to the number of rows that we have. So you see this another example of the AMP that we had. So with the first one which was C and D was the answer is the result is B and then so with the first one which was C and then we have B, C, and then C is possible. Then we have B, C, and then C. So B and C, can we multiply B, C? Is that possible? So B and C, can we multiply B, C? Is that possible or not? Is it possible to multiply B and C? Is that possible? Is it possible to multiply B and C? Is that possible? Yes, Evans.
Yes, madam, it's possible. With the B,
Yes,
B has three columns.
possible.
Was with the B has
three rows, sorry.
three columns. Was
So
C
then it's
has
possible because the number of three rows and the number of rows are the same. Yes. Is the opposite true? Because can we multiply C and then B are the same? Is the opposite true? Can we multiply C and then B? C and B can we multiply through it? Anyone? Is it possible for us to multiply? Can we multiply through it? Is it possible for us to
madam, please, it's
multiply?
not possible.
Yes, because now we have one
Madam, please, it's not
column,
possible.
but then the other has
Yes,
now
and
we have one, then the next column on the square, but then the other has
yes,
square and then b square. Then the next was on the square root. This so e square is basically e times e. So e square is square. This multiplying square is with itself e times e. Is that possible? So multiplying e with itself e times e, is that possible? Yeah. Any ideas? Yes, any ideas?
yes, please, it's possible. The rows and the columns are the same.
And the columns are the same.
Yes,
What
please,
of
it's possible.
B times
The
B?
rows and
Is
the
it
columns
possible
are
for us to
the same.
multiply columns are the same? What of B times B? Is it
B,
possible for us to multiply B with itself?
B.
Yes. Yes.
I think B times B will not be possible.
Why?
I think B times B because the first B has because three columns. The first B has
Yeah.
three columns.
Two rows.
What's the second one? Two rows. Yes, please.
Yeah,
Yes.
it's not
Two.
going two rows. Yes.
It's two,
So we
two
just
rows.
note
Yes,
that.
please.
So
Yes.
everything we see that the dimensions play. So we just note that. So for the addition and everything, we see that the dimensions play a role. While for the addition and subtraction has the exact number of dimensions. Columns in the first is equal to the number of columns in the first is equal to the number of rows. Kumandere, you can unmute and speak. Mr. Derek, come on.
I wonder how we.
Mr. Derek, come on. Pardon?
I wonder how we. Okay. Yeah. Okay.
Is it my internet or your internet?
Please, I wanted to find out where we are taking that.
Internet. Where we are. I
Please, I
shared
wanted to find
the
out where we are taking that.
query it's a Google form. I shared the so I've shared the form. So when you open it's a Google form, you just enter your so I've shared the form. ID. So when you open the form, you just enter your name. Then it's requiring for session 1 attendance. You just write two attendance, and then it's requiring for session 1 attendance, last week 2 attendance, and whether you joined online or you were with session 1 was on last week Saturday. You just whether you joined online or you were session 2 was Monday's online class, you just and then session 3 is today's session 2 was Monday's class, and then session 3 is today's class. So that's basically just take what we are doing right. I've shared the attendance to that again. Basically what we are doing right. I've shared so the links are the same. Whichever you click on again will lead you to the same form. Yes, so the links are the same. Whichever you click on. So now we are going to the final aspect, which is on the symmetry. Okay, so now we are going to the final aspect, which is on the length that symmetry and then the transpose. So we learned that to be able to find symmetry first, and then should be the transpose of that should be the same as the original. It should symmetry. The transpose of that should be the same as the original. So symmetry, and transpose. So let's see. Symmetry for A, transpose. So transpose means we are for A. Flipping if we were to transpose, so transpose means a row. So column one becomes where the column becomes a row. Three becomes column one becomes row one. If we do that for matrix A, three becomes is the value the same as what if we do that for matrix then based on that is the value the same as what we started with. Then based on that is it symmetric or not? Any ideas?
Madam, please, it's not symmetric.
Why?
Madam, please, it's not symmetric. When we turn it,
Yes.
the figures that started with the matrix A won't be the same.
Yes.
The figures that started with the matrix A, the result won't be the same. And the column will be the same as that's the column currently, but the result at the column will be the
So
same as
currently what we have is that the
currently
first
what
is 5, 4, so currently what we the have next one is 4, 0, 5, 4, and then the next one is the 7, 10, 4, 0. If we are to flip it, and then the next one is 7, 10, 7. If we are to flip it, what we'll get is 5, 3, 4, 7. That's totally different. So the other is 10. And then 3, 4, 3. That's totally means that so the other is close and the same. The values are not the same. Then it means that A transpose and A are not of matrix B. Then it means that is matrix B symmetric. What of matrix B? Is matrix B symmetric?
Yes, please. So, it's symmetric.
Yes, yes. It's symmetric because
Yes, please. So, it's symmetric.
we still get the same value. It's symmetric because if we 3, 4, which is the first column, if it becomes the first, so if we the 2, 3, 4, which is the first column, minus the first 3 minus 2, 4, which is the second column, minus when it becomes the 3 minus 2, 4, it is still which is the second column. When it becomes the second, the last column. When it becomes a row, it's still and then the 4, 4, 4 for the last column. And when it becomes a row, it's still 4, 4, 4. So it means that B symmetric. And then B transpose. What of matrix C? Which means that B is matrix C symmetric. What of matrix C? Is matrix C symmetric? Yes. Is matrix C symmetric? Yes. Very. They are not symmetric. The first rule even says that to be symmetric first you have not symmetric. This is the first rule even says that to be symmetric first you have to square. This is obvious has not a square the 2 columns. The 4 times not a square by 2 matrix has from that you can obviously see that it's not a square means that it's not going to from that symmetric. If we flip it from there we'll end up getting the 2 by 4 symmetric. If we flip it we'll end up getting the 2 by symmetric. What of matrix D? D means that it's not is D symmetric. What of matrix D? Yes, Goswell. Is D symmetric?
Yes, please. It's symmetric.
Yes, because if we flip it, 3, 0, 0.
Yes, please. It's symmetric.
0, 0. Because if we flip it, 3, 0, 0 becomes 0, 0, 0. 0, 4, 0 becomes 0, 4, 0. So because the values are 0, 0 is the same. 0, 0, 0. And then D because the values are maintained is the same. It is D symmetric. And then D transpose. What of matrix E? Which means that it is symmetric. What of matrix E?
No, please. It's not symmetric.
Because the first row.
No, please. It's not symmetric.
3 minus because 3, the first row, the second row is 3, 7. Minus 3. If we were to flip it, the second row is minus 1, 3, 7. And then the second row, the first 7 becomes minus 3, 1. And then the second row will be 2, 7. So you see that there has been some change. Which means that E transpose and E symmetric. that's E. Then the last one, which is the matrix symmetric, is F symmetric. Then the last one, which is the matrix, yes, Max, F is F symmetric.
Yes, please. It's symmetric.
Yes, Max. Yes, symmetric because
Yes,
if there are
please.
10
It's
in
symmetric.
order, it's still the same as symmetric because if there are 10 years in order, that is still the same as symmetric. So the first column of matrix F is that 1 F minus 1 5. So the first column of matrix F is 1 minus 1 5, which is the same as the original that we started with. Is 1 minus 1 5, which is the same as the original that we started with. If that the second column is minus 1, what we originally started with. If that then the third column is 5, the same as what we originally started. If that becomes, and then the third column is 5 1 which is exactly the same as what we still started with, which means that which is exactly the same as what we started with, which means that matrix F the solutions for symmetric questions. I have it. So I wanted us to discuss solutions for these questions. I have it. So I wanted us to discuss it first to include then our solutions, and then update this. I'll share that with the solutions so that we have then a copy of it. I'll share that with all of us. So as I was saying, let me a copy of it. So that's what we should know. So as I was saying, let me see if I let's take a little look at the course outline so that we see where we are. So let's take a little look at the course outline so that we see where we are and then okay. So for the course outline means we have done here, we've done out to here. Okay, so for the course outline means we have done on here, matrices. Here. So the next that we are going to start basics, that's for next matrices. We'll look at so the next that we are going to then we'll also look at that's for next week is we'll look at determinants and then also look at the inverse of a matrix. That's so determinants and then the inverse of the matrix. That's for Tuesday. God willing, next week Tuesday. We have that. So we can have it on Tuesday. On the God willing, next week the same we have that. Look at the applications of the same week. So that's what the application next week is matrix basically on application. So that's what it says that we start with determinant. So next week is and then for basically on application of look at solving simultaneous equations and then for Thursday we look at solving simultaneous equations and then that's when you the total recap on what matrices is. Then that's when you will also get the first class assignment based on the matrices. So from the basics, the addition, subtraction, multiplication. So from questions on the basics, the addition, subtraction, multiplication, some questions on determinants. Then that same questions on that's during the Saturday class. That's equations. Then that same differentiation. That's during the Saturday class. Basically that's plan for next week. So next week we focus on applications. This is basically the plan for next week. So next week you focus on applications of matrices. Do a matrix topic review of we start with differentiation. Matrix topic, just keep that in mind as we start with differentiation. So we just keep that in mind as we today. So we are done for today. Please let's fill the that's it for today. So we are done for today. 8 people have please let's fill the seminar. We are still 3 people also have 8 people have filled. So guess in line either 3 people also have. So please if you haven't filled it, you can just yes you can just either 3 or 2 events. So please if you haven't
Please, I can't find a link for it for the forms.
So at the comment,
Please, I can't find a link for it for the forms.
So at the comments, they just so the message box or comment form. So you just click on the link again. And so the mark this, they are just shared it now. So you just click on. I hope you've seen it now. And you mark the at the message box or comment. I hope you've seen it. Just click on it. So it's just requiring your the message name and comments. If you don't have ID on it, so it's just requiring them for the session name and just indicate with yes. If you don't have ID, yes, just enter fresh one. Then for the session, you just indicate with yes or yes, so that which one is campus and which one Okay, so that's it for today's class. But as with the yes, we have questions. So that's it for today's class. Thomas has a question. Yes, we have questions. Thomas
Hello,
says
madam. I
Thomas first.
want to
Yes,
know
Thomas has a
on
question.
this set
Thomas says
hello,
yes.
madam. I want to know diversification. Will be on class on campus or be online like this? Diversification
So
will be
that's
on
I'll let
class
you
or
know next
on
week.
campus or be online like
So
this?
next week,
Okay, but
there's
we
I'll
want to
let
do
you
that
know next
if we were here,
session.
then we will start ourselves.
So next week,
Okay, but
there's
we
going
want
this
to do
week
that
has
if we
CV
were here,
session.
then we will start
Next
ourselves.
week has KCC session. This week has CV session. CV. So next week, don't worry, I'll let you know. I'll not let you. So next week, I don't think there's going to be CV. I'll let you know. Next week, don't worry, I'll let you know. I'll not let you know having in person. So I'll let you know before the session. So next week, I'll let you know having in person. Yes, we will have it online. So next week, I'll let you know hand up, and then you just prepare accordingly.
Yeah, madam.
There was
Madam, please, I
another
wanted to, if you can go back to question one.
yes, question
I
one.
wanted to
Yeah,
ask,
madam.
madam, please,
Yes,
I wanted
please.
to, if
I
you
want to
can
ask
go
some
back to
questions.
question one.
Question
I
one
wanted to
on
ask
the
some
addition
questions.
and
Yes, please.
subtraction.
I want
Okay.
to ask some questions.
Yes,
This one. Question one on the addition and
Yes, please.
subtraction. Yes.
I think
yes.
This one.
the
One F,
yes, please.
where
Yes.
he asked whether
I
A
think
plus E,
A
the
plus E.
one F,
Yes.
yes,
where
can be
he
worked
asked
out.
whether A
Okay,
plus
so
E.
I think from the last
A
slide, if I
plus
got you
E.
correct, you
Yes.
said
Yes, can be worked out.
if there's
Okay, so
if
I think
there's
from
any
the last
two
slide, if I
column,
got you correct, you
Yes.
said you can use a
if
transpose
there's
method. If
there's
interchange
any
the two
two
and
column
make it
Yes.
into
you can
rows.
use a transpose and
No, no, no,
So
no,
interchange
with
it
it
no.
and make it
okay
into rows.
For addition, no, no, no,
So
no,
with it,
no.
okay,
Subtraction, no. If we
okay,
for addition and matrix, just like subtraction, you take the
okay, okay,
matrix as the matrix,
oh,
as their what is their
okay,
size as their do they look
oh,
alike? As their what is their size? Is it the same? Do they look alike? Like they are from like siblings? Then it means that we can add or subtract the same. If you take a look at, then it means that A's length is more on the row side. It has A length is more on the interior side. It has more of height for like instance, but then E has height. But then A has the height for like they are not E has height, but then A has the breadth. So they are not the same. They are not from the same family. So we can't do the
yes, please,
addition or
thank
subtraction.
you,
For addition and subtraction, all we are checking
yes,
is
please,
that how is it the
thank you,
same for addition and subtraction? All we are checking is that how the same size it is. Then if we can add, then we can do the subtraction. Let's see. Steven, you have a question. We can do the subtraction. Let's see. Steven, you have a question. Steven, do you have a question?
Yes, madam.
Yes. What's the question? Steven, do you have a question?
Please, yes, madam.
Yes. What's the question?
Concerning the please symmetric matrix.
Yes.
Concerning
and then
the
we will use
transport. I'm not
symmetric
getting it, but
matrix,
Yes.
and
I would
then
like
we
to
will use
do my check.
transport,
And then if
I'm not
I don't
getting it,
understand it,
but
the next time we meet, I would
I'll
like to
ask.
do my check.
Okay.
And then
Okay.
if I
Okay.
don't understand it, the
So
next
you
time we
just
meet,
do further
I'll ask.
review, and then the next time we go through it.
Yes,
So you
please.
just do further symmetry, and then the symmetry comes from the
Yes,
transpose.
please.
So if the transpose and then the symmetry comes from the original, but if the transpose is the same as then we can say that is symmetric. But then before you started, you check that we can say it's a square matrix. But then if it's 4 by 4, check that it's a square matrix. If it's 4 by 4, if you get it, we still get 4 by 4. But if it's 3 by 2, if you go and make it, we still get it becomes something else. But if it's 3 by 2,
Okay.
if you go and take it becomes something else. And then you notice that will be. So
Okay.
let me take the last question. Thomas, and then you notice accordingly. let me
Yes,
see
madam.
that.
Please, are you going to have this twice? Then we will go back over and
Yes, madam.
do
Please,
our checks
are
and
you going to have
everything.
this twice?
Then we will go back over and do
Okay.
our checks and
Check the
everything.
WhatsApp group. Yeah, just like I've shared it already. It's this same slide, so
Okay.
it's not going to check. The only thing is that it becomes more. I'll be update. It's the same slide, so it's not going to change. The only thing is that it becomes more here. So if you remember, and the first now I slide that I shared is still the same document. This so the next that I'll add now I have included this. It's still the same for each of the questions that I'll add is the I wanted us to discuss it before I include that of the questions. So the next is I'll include I wanted us to discuss and share that before I include next week's class when so the next is I'll include that and then I'll share that too. The slides for that when we start with the determinant for each they actually after each session the slides for that also check for the message from me for each on this slide after each session just check for the message from one that you have on this slide then that one you just the latest version so let's all this because what I share so after each the latest version for each class just check and see that so after each class a new before lecture just the name will still be the same math 104 lecture a new lecture note so the name will still be the same math 104 lecture yes that means that's the latest version has there been a new math 104 lecture note if yes that means that's the latest version you just download that so as I was saying as with the previous class keep this has been recorded that's how I was saying as with the previous class YouTube and then this has been recorded playlist try and then upload it on the playlist down here share it on this one playlist that's so the course playlist if you click on this down here lead you to the this one video that's the course of all the weeks it will lead you to the notes of video and then of all the weeks watch that take notes of can listen to everything you want to read to revise what was watch that you just go through can listen to it miss a class you can revise what was done in class you just go through it or if you miss a class you can just refer to that and then you'll be able so thank you very much for coming for today's class afternoon so thank you very much for coming for today's class and then regarding the Saturday class I'll let you know next week if we have it regarding the Saturday class I'll let you know next week if we have it next week you get the information so that you are able to prepare online well for next week you get the information so that thank you once again and then prepare well for the class next week so thank you once again and then see you hopefully next week Tuesday.